This is Earth 4 billion years ago. There was no oxygen in the air. Molten lava flowed into an already poisonous sea. Hard to imagine, but this harsh environment was perfect for nurturing a miracle. Rain washed the necessary chemicals from the air, and lightning and ultraviolet radiation cooked these chemicals into an organic soup. And somehow, when the smoke cleared, there was something new, something amazing. A very, very special molecule with a graceful spiral shape. And it had talent. It could make copies of itself faster than it could be destroyed. This was the origin of life on Earth. And when this molecule learned to protect itself inside cell walls, life began to transform the planet. 3.5 billion years ago, cells learned how to directly use the sun's energy in the process of photosynthesis, and life grew exponentially. The oceans teem with cyanobacteria, and layers of these microorganisms mixed with sediments became the world's first living structures, stromatolites. For more than 1 billion years, these 3-foot-high mounds marked the limits of life's progress. But more important than the mounds themselves was their waste, oxygen. These new gases, at first toxic to all life, gave rise to the ozone layer. Shielded for the first time from the sun's damaging ultraviolet rays, life became unstoppable. One and a half billion years ago, the cell developed an additional membrane to protect its genes, a nucleus. Now, life was so abundant that every drop of water teemed with organisms. 800 million years ago, the first multicellular organisms began to appear. For a while, multicellular animals just meant collections of identical cells. But gradually, these colonies began to have cells that were specialized for different purposes. The first multicellular animals that had specialized cells were sponges. Some of the cells pumped water, and some filtered out tiny bits of food. Anemones and their relatives had muscle cells and nerve cells. This enabled them to bend, stretch, and flex. But none of their great cell diversity enabled them to move. Staying put was a common trait back then. "600 million years ago, an ancient worm was the first animal to develop a centralized nervous system. It had nerve cells that ran the length of its body, and a concentration of these cells at one end formed the first primitive brain. In fact, this was the first animal with a head, and light-sensitive cells in that head were the world's first eyes. It could recognize both the direction and intensity of light. Since it could both see and move, this worm interacted with the world in a very different way. For 100 million years, sponges, anemones, and flatworms dominated the ocean. Then, all of a sudden, if you can call 30 million years sudden, a huge variety of creatures appeared. This event is called the Cambrian explosion. Here is a stunningly developed marine worm. In the course of the Cambrian explosion, competition for food caused both predator and prey to become extremely sophisticated. This is the top predator of that period, a terrifically capable hunter. The Cambrian was a very dangerous time. Only slightly lower on the food chain, another deadly predator prowled the ocean depths. This one had 5 eyes on top of its head and a single extendable claw it used for hunting. Every animal group alive today had its origin in the Cambrian. The first fish appeared more than 500 million years ago, a predecessor to mankind's own group, the chordates. Fish quickly became a success story, getting faster and sleeker and far more numerous. They developed bony spines and, crucially, jaws with teeth. "400 million years ago, much of the earth was already covered in green. Plants had colonized fresh waters and spread onto land. Once they were established, animals soon followed. Centipedes were among the first land creatures. They developed simple lungs and skin that retained vital water. Scorpions, cousins of the horseshoe crab, also made an early move onto land. Their line of 8-legged predators has spread far and wide since then. While the invertebrates were the first animals ashore, others were not far behind. Fish penetrated weed-choked lagoons. Using limb-like fins, they pushed their way through the tangle to stalk their prey. Fins became more and more like legs. The vertebrates were on the verge of a breakthrough. The first amphibians emerged from the swamp some 370 million years ago. Their soft, moist skins absorbed oxygen, and simple lungs allowed them to breathe air. The exertion of hauling themselves over land required plenty of fuel. But the land was now crawling with life. The first flightless insects made easy prey. Many amphibians came to live on land because food was so plentiful. But they were forever confined to the damp places because of their delicate skins. Reptiles evolved from amphibians. But with tougher waterproof skins, they were able to occupy entirely new habitats. Reptiles also pioneered another breakthrough: waterproof eggs. Now they could breed in dry places. Inside the eggs, developing young were housed in a miniature ocean. Reptiles were on the verge of global domination, but one thing held them back. With their skin now waterproof and airtight, breathing became a problem. Lizards breathe by expanding their chest, but because how they walk, they often have to hold their breath. Their waddling gait, inherited from ancestral fish, forces the chest to flex as they walk. Their lungs can't expand to draw in air, and lizards easily become breathless. Ancient relatives of the crocodile, though, found a solution. By standing up on their legs, these reptiles began to walk tall and breathe easier. 270 million years ago, it is hot, and these ancient reptiles need plenty of water. Spending time at the river makes the herds nervous. They know this is a great place for an ambush. Fortunately, this top predator is not hunting. She has recently eaten and also has come to the river to drink. She is 18 feet long and has an armored back. She needs a huge amount of food and therefore needs to defend a very large territory. The only creature on the planet she fears is another one of her kind. $220 million years ago, there's only one giant continent called Pangaea. It is a harsh place mostly covered by deserts. This line of ancient reptiles has met all challenges for more than 100 million years. But now there's something new. A family of reptiles destined to shape the course of life on Earth for the next 160 million years. These are the first dinosaurs. This small raptor has survived the drought along with others of her kind. But they have now been joined by another type of dinosaur. A herd of platysauruses has been drawn to the river. It is hard to believe that these four-legged giants are related to their small cousins. But they are a plant-eating dinosaur. Their size is the key to their success. At 4 tons, they are just too big to be threatened. This is the shape of things to come, and their descendants will only get larger. Further down the river is one of the period's most interesting animals. This is a connecting link between the reptiles and the mammals. As he runs, his backbone moves from side to side like a reptile's, but he has hair and lives in a burrow like a mammal. Deep inside, his mate sleeps on a bed of lichen. The bond between them is strong, and they pair for life. Like all land reptiles, they lay eggs, but after hatching, their young are very dependent and spend most of their months feeding from special milk glands on their mother's stomach. The Jurassic is a time of colossal seagoing monsters. Full of creatures bristling with spikes and clubs, horns and frills, and mountains of flesh so huge they shook the ground beneath them. $125 million years ago, slow movement of the continents is breaking up the northern and southern landmasses, raising sea levels, and opening up new seaways and coastlines. Where once there was solid land, now there are rigid cliffs filled with flying reptiles called pterosaurs. Pterosaurs have been around for 100 million years, and some species are now huge. Wingspans of 20 feet are common, but there is a species that dwarfs them all. This giant is 40 feet from wingtip to wingtip, with a body bigger than a man's. He is the undisputed king of the skies. This little mammal is a scavenger. She is a marsupial and specializes in raiding abandoned dinosaur nests. This evening, she thinks she is in luck. Unfortunately, the smell of food has blinded her to the danger. "65 million years ago, a meteor just 10 miles wide abruptly ended the reign of the dinosaurs. "3,000 miles to the north, the effects are about to arrive. The light from the impact fades in silence. The shockwave arrives. Next comes the blast front. Finally, a rain of molten rocks starts to fall out of the darkening sky. The meteor hit the Gulf of Mexico with a force of 10 billion Hiroshima bombs. With the catastrophic climate changes that followed, 65% of all life died out. It took Earth millions of years to recover, and when it did, the dinosaurs were gone forever. It is a time called the Eocene, and Earth has healed itself from the ravages of the massive meteor strike. A lot has changed since the time of the dinosaurs. It is hotter now, and tropical rainforests have sprung up on every continent. The top predator now are the dinosaurs' direct descendants, the birds. There are many varieties in this weird habitat, and the largest is 1,000 pounds of muscle and feathers, and is as tall as a grown man. From small beginnings, mammals are now prepared to take over the world. Over the course of 40 million years, mammals have become more and more successful until they are the biggest, fiercest, and most spectacular animals on the planet. Whatever the climate and whatever the habitat, mammals made it their own. Their great strength was the ability to adapt. They grew in huge sizes. They evolved into powerful killers, and they laid their claim on the oceans. And then, around 6 or 7 million years ago, we have our first ancestor that is not also an ancestor of any other living creature. This is Tumai. It is the oldest known hominin, and dates between 6 and 7 million years ago. Auroran dates about 6 million years ago and was probably bipedal. Ardipithecus lived from 5.8 to 4.4 million years ago. This is Kenyaanthropus, from 3.5 million years ago. This is Lucy, an Australopithecus afarensis, from 3.2 million years ago. Meet Australopithecus africanus. He is from 2.5 million years ago. Homo habilis, from 1.9 million years ago, was found with tools. Homo ergaster dates to 1.6 million years ago. Homo erectus lived from 1.8 million years ago until 300,000 years ago. This specimen is from 500,000 years ago. This woman is the mother of all mankind, the common ancestor from whom we all descend. She lived 150,000 years ago in East Africa, and everyone on Earth is related to her.